Hello and welcome everyone to video number 3 about OpenGl ES. So in this tutorial, we will be cleaning and explaining about the codes from the previous video. So first of all, I will try to isolate the shader code and put that in an asset files. Then I will show you how you can write error handling. I will not be using that in everywhere. However, one should do that. Then I will show you how you can draw multiple triangle, and I hope that you will get more insights about the functions that we used in the second video. This is the code from the previous video. So we already have our triangle in white drawn on a background. So in this video, first, I wanted to show you how you can add an error handling function. So in OpenGL, there is no throw exception. Instead of that, one can check after each OpenGL command if an error occurred or not. For that, I will copy and paste small function, this function called check error. I'm using here an integer. I will show you the purpose of this integer later. So this function calls the OpenGL command called get error. This will return an integer. So if this integer is a 0, then that means there is no error. If not, then there is an error, and the error code is represented by this integer. For now, I will just be logging this error. I will be using this error handling in the shader loading code. Now let's try to make our code cleaner by taking these shader codes and putting it in files. So I will go first here to the application and add an asset folder. So here you can search for new directory, and then we search for main assets, and this in the asset directory we can add shader files. Yeah, I will call our shader simple, and I will be adding a vertex shader and another simple also, however a fragment shader. As you can see, Android Studio has already added some skeleton code for us. However, I will copy and paste the code. Yeah, this is the same code which we are using in the Java. You can see here. So for the vertex shader, we're just defining a version, position, and returning this position. Yeah, and that's exactly what's happening here. However, now we get this syntax coloring, and we can see that already Android Studio can help us detecting some errors. For example, if we added extra commas or so, you get some warnings or actually errors here displayed from Android Studio. So you get some help now in syntax completion also. Here, nice syntax coloring and helper. I already installed an extension for Android Studio. As you can see here, if we went to the settings and then to the plugins, you can see the installed plugins, and I have a GLSL plugin installed, and that will recognize the OpenGL syntax. That's all. So now we have an assets folder, and inside it we have this symbol, fragment, and vertex shader. Next, we need to read these two files, and for that I will copy a function which I already prepared for you. This function is called read asset file, and it needs as an input the file name. So in this case, for example, we give it a file name either simple.frag or simple.vert. The function simply calls getStreamOpen to return a stream representing this file name, and then create an input stream reader which can read from this file, and finally a buffer reader around that so that we can make read line from this buffer reader. And what we do is simply, while this file is not finished, we read a line and then append that to our string builder, and then we return this string. And of course, there is some error handling in case of an IO exception, since opening these streams could throw an IO exception. And finally, we close the reader in either cases. So an error happened or a successful reading. Here I'm missing the tag. So the tag is only used for debugging. Let me define that. So this is taken from the class name. So it would simply be like main activity. That's all. Now we can read an asset file and return the text included in this file as a string. So the next step is to read these two files and then compile them and put them in an OpenGL program. So basically we will be refactoring this part of the code. So for that, I will add another function called compile shader. I already prepared also this function for you. So I will copy and paste it here. As you can see, this function expects two inputs, a name and a type. So this would be the name of the shader and its type. Is it a vertex shader or a fragment shader? So in our case here, this will be, the name will be simple in both cases. And then we will have the type in one call as a fragment shader and in the second call as a vertex shader. So if the type of the file is vertex shader, we add the extension .vert to the file name, and then we read it. If this is a fragment, then we add the .frag extension, and then we read the file. Then as before, we create a shader of the corresponding type. We add the source, which we already read from the asset file, and we compile the shader. This is the same code as from the previous tutorial. However, now I added this error checking code. So this error checking code is based on this OpenGL command where we get the status of our compiled shader. If the return status is 0, then there is a compilation error, so we can read it using this OpenGL command here. And actually what I do here is only I log this error and then delete the shader. And that's it. So if everything went well, then we have our shader and we return the shader ID. Now we can create our program, and for that I also prepared another function called create a program. This function simply call compile shader for a vertex shader and then compile shader for a fragment shader. So now we have both vertex and fragment shader, and the same as in the previous video. So now we can create the program and attach both shaders to it, then link the program. Here I'm calling the function check error. So I will actually put now this integer to 0. And then also here I added some error check code where I get also the link status of the program. And if there is an error, then this will be logged. And that's it. So we will return the program ID. Now we can delete this code from here since we already now have it in the assets. And then we can refactor here our function. So the code now for creating the shaders and the program can be deleted and replaced only with this function called to create a program, and we pass the name of the program, which is simple. That's it. Actually, we don't need now to add, the program is already attached, and then we just use the program, and that's it. Now the code to create the OpenGL program is already isolated from the rest of the OpenGL initialization code. Let's run and make sure that the program is working. So as you can see, it is working, no problem. So one last step regarding error handling, I want to add this error check in the drawing function. So I will go to on draw frame and add this error check. And I usually like to define this integer loop and set it to 0. And then in each time this on draw frame is called, I will increase this loop. I do this to distinguish the error happens on draw frame calls from the error which happens on the initialization of our buffers and programs. And that's it. So the program should still be working now. Okay, I will show you now why this error handling code is useful. So let's assume that we made an error here. For example, we forgot to put the ES indicator in the version, and then we run our program. As you can see, there is no coloring happened here, and that's because there is an error in our compiled code. So we can check that either by looking in our logcat and then searching for an error in main activity. As you can see here, there is a compilation error, or we can put a breakpoint. I usually put breakpoints here and also here on creating program and in the compilation of the fragment and vertex shader. So now if we run the debug, as you can see, we have here our compilation status, which is not 0, and then we have our error string, and it's saying invalid version of the directive, as you can see here. So then you can simply come to the shader, fix this, and rerun, and everything is working again. The last thing I want to show in this tutorial is how you can draw more than one triangle. So here in vertex data, we defined our triangle using these coordinates. OpenGL uses a coordinate system which starts from -1 on the x-axis till 1, the same for the y and z axis. That's why this coordinate is being displayed like this. In this current program, we have 3 vertices, and in our draw command here, we are telling OpenGL to draw triangles, and we are telling it also that there are only 3 vertices. What we will do now, we will add another 3 vertices here, which will represent a second triangle. The second triangle will have 2 vertices here, which are the same as the previous triangle. However, the third vertex is different, and it will show up here in this place on the screen. Now, if we run the program again, you can see we still have only one triangle. That's because we are telling OpenGL to draw only 3 vertices. So now if we put it to 6 vertices, then that means we have 2 triangles, and we have now 2 triangles. This parameter here is telling OpenGL about the offset. So if we said, okay, we want to draw only the second triangle, so we tell it that the offset is 3 and we only need to draw 3 vertices. So now OpenGL will be drawing the vertices from 3 to 5. So vertices 3, 4, and 5. And that will result in only drawing the triangle here at the bottom. Yeah, I will go back now to 6 triangles. The last thing I want to say about this OpenGL draw command is that it accepts 3 kind of primitives. So here we are using triangle. There is another primitive called points, where now OpenGL will draw these 6 points, and lines, where OpenGL will draw lines connecting these vertices, as you can see now. Yeah, so here, I don't know if you can see it. I will make it bigger. So here, you can see that these are the lines connecting the vertex in index 0 and 1, then 1 to 2. Then if we have like 2 to 3 and 3 to 4 and finally 4 to 5. That's all I wanted to show in this video. Thank you for watching, and see you in the next video. Bye.